So in this video we'll pick up from where we left off, and so we saw that we have this triangular shape. We do know that at the end of it, by the way, that the velocity goes down to 0. So again, we're trying to find the distance in which the car can be brought to rest from 30 miles an hour. And since 30 miles an hour is 44 feet per second, so what we're trying to find out is at time B, and we don't not ask for what that time is, but we're trying to find out um, the distance that is going to be required for the vehicle to be brought to rest from 44 feet per second, assuming a constant deceleration. So we've figured out, first of all, that the time between when it's first clocked at 66 feet per second to when it is clocked at 44 feet per second with a constant deceleration was 264 over 55, which comes out to be exactly 4.8 seconds. Now what we're trying to find here is the area of this triangle, and that will be the number of feet that it takes the vehicle to be brought to rest from 44 feet per second. So we're looking for that area. In order to find that area, we do already know the height of that triangle. We need to find the base of that triangle. And the way that I went about this at this point, especially seeing that we have a constant deceleration, which means that our velocity is a linear equation, or it's a linear graph, then it has a constant slope throughout its entire domain. And so I can solve for that slope, or I can make a proportion based on that slope. So the change in y would be 44 minus 66, and the change in time would be 4.8 seconds. So we would have negative 22 over 4.8, and that would have to equal the change in y of the triangle, which would be it would be 0 minus 44, which is negative 44, and the time, which we don't know, we'll just call x. So at this point we can cross multiply. We get negative 22x is equal to negative 211.2, and dividing both sides by negative 22 we get that x is equal to 9.6. So it was 9.6 seconds, which just happens to be double what the first interval was, and I'm sure that there's some relationship there. But now we do know that the time it took to bring the car to rest from 44 feet per second is 9.6 seconds. And if I'm looking for the area, I can now set up a fairly simple area of a triangle formula, and that is just 1/2 of base times height, where the base is 9.6 and the height is 44, which just comes out to be 211.2 feet. So the area under the curve from t equals a to t equals b is 211.2 feet, which means that is the distance traveled from time t equals a to t equals b. That is the time it takes for the car to be brought to rest from 44 feet per second. And so you have 211.2 feet there. And so on one hand, this is just using this, I guess this is a great illustration of doing the calculus using areas of known geometric formulas. And but also it does involve calculus in that you have the area under the curve being something. So the area under the velocity curve giving you the distance traveled. And in the next video I'll show how we set this up, doing this completely mathematically, I guess, without even a without needing to have a graph here. But this way is very clear for me to look at it, and again it's a very acceptable solution to the problem. But that is the correct answer, and I verified that in the solution manual. So if you got that answer some different way, that's very good. I will continue this in the next video and look at the same thing from a completely calculus perspective.